Quadratic polynomials. In this module, we will learn about quadratic polynomials. The quadratic polynomials are the polynomials having degree 2, generally written as p of x equal to ax square plus bx plus c, where a, b, c are the real constants. Example, 2x square plus 5x plus 3 is quadratic polynomials. Here 2 is degree of quadratic polynomial. The value of quadratic polynomial can be obtained by substituting x by k, such that we get p of k is equal to ak square plus bk plus c. Consider a polynomial p of x. If k is a real number such that p of k equals to 0, then k is called a zero of the polynomial p of x. Let us take an example. The zeros of polynomial p of x equals x square minus 6x plus 9 is 3, because p of 3 is 0. Now let us understand relations between zeros and coefficient of a quadratic polynomial. In general, if alpha and beta are zeros of the quadratic polynomial p of x equal to ax square plus bx plus c, where a is not equal to 0, then by factor theorem we get x minus alpha and x minus beta are the factors of p of x. Therefore, ax square plus bx plus c equals k into x minus alpha into x minus beta, where k is a non-constant. That is, equals k into x square minus x into alpha plus beta plus alpha into beta. Now, comparing the coefficients of x square, x, and the constant terms on both sides, we get a equals k, b equals minus k into alpha plus beta, and c equals k alpha beta. Hence, the basic relationships between the zeros and the coefficients of p x equals to ax square plus bx plus c are sum of zeros, that is, alpha plus beta equals to minus of b by a equals to minus of coefficient of x by coefficient of x square. Then product of zeros, that is, alpha into beta equals to c by a equals to constant term by coefficient of x square. A quadratic polynomial p of x equals to ax square plus bx plus c may have at most 2 zeros. Now, for any a not equal to 0, a into x square minus alpha plus beta into x plus alpha beta is a polynomial with zeros alpha and beta. Since we can choose any non-zero a, there are infinitely many quadratic polynomials with zeros, alpha and beta. Find the zeros of the quadratic polynomial x square minus 2x minus 8 and verify the basic relationships between the zeros and the coefficients. Solution: let p of x equal to x square minus 2x minus 8 equals to x minus 4 into x plus 2. So, if p of x equals to 0, that implies x minus 4 into x plus 2 equals to 0. Therefore, x equals to 4 or x equals to minus 2. Thus, the sum of zeros will be 2 and the product of zeros will be minus 8. Now, verifying the basic relationships between zeros and the coefficient, we get sum of zeros equal to minus of coefficient of x by coefficient of x square. We get minus of minus 2 by 1 equal to 2. And product of zeros equals to constant term by coefficient of x square. We get minus 8 by 1 equals to minus 8. Thus, we can see that by both methods we get the same answer. Thus, the basic relationships are verified. Find a quadratic polynomial with zeros at x equals to 0 and x equals to 4. Solution. Let alpha and beta be the zeros of p of x. Now, using the relationships between zeros and coefficients, we get p of x is equal to x square minus alpha plus beta into x plus alpha into beta equal to x square minus 0 plus 4. X plus 0 into 4 equal to x square minus 4x plus 0. Thus, x squared minus 4x plus 0 is a polynomial with zeros 0 and 4. There is an alternate method by which also we can find p of x by multiplying x minus alpha into x plus beta. Any other polynomial with the desired property is obtained by multiplying p of x by any non-zero real number. Let us summarize all that we have learned in this module. Quadratic polynomial.